The first reaction is the addition of dilute sulfuric acid to aqueous calcium nitrate, which is a precipitation reaction. A precipitation reaction occurs when two aqueous solutions are mixed together and an insoluble salt is produced. The H2SO4 sulfuric acid molecules have weak intermolecular forces of attraction between discrete molecules and strong covalent bonds which are electrostatic in nature between the hydrogen and oxygen atoms, whereas the calcium nitrate has strong electrostatic forces of attraction between the Ca2 plus and NO3 minus ions. At first, when the two solutions are mixed together, the sulfuric acid dissociates to form H plus and SO4 2 minus sulfate ions, while calcium nitrate dissolves to form Ca2 plus calcium cations and NO3 minus nitrate ions. Firstly, the H plus ions will want to achieve a stable electronic configuration, so they easily bond to some of the lone pairs of electrons in the oxygen from the H2O water molecules to form H3O plus hydronium ions. This is known as a dative bond as oxygen shares one of its lone pair electrons with the H plus, while H plus does not share any with the oxygen atom. The calcium cations will be attracted by strong forces of electrostatic attraction with the sulfate anions due to large differences in electronegativity, coming closer and closer together and forming an ionic bond. As you can see at the bottom of the screen, when aqueous sulfuric acid reacts with aqueous calcium nitrate, it produces solid calcium sulfate, aqueous hydronium, and nitrate ions. The hydronium ions would have strong covalent bonds between the hydrogen atoms and oxygen atom, where one hydrogen atom has a dative bond with the oxygen atom. However, hydronium has a simple covalent structure and there are only weak intermolecular forces between the discrete hydronium ions. On the other hand, the nitrate ions would have strong covalent bonds between the oxygen atoms and nitrogen atom, where one oxygen atom has a dative bond with the nitrogen atom. However, just like hydronium, nitrate has a simple covalent structure, and there are only weak intermolecular forces of attraction between the discrete nitrate ions. Over time, more calcium cations and sulfate anions come together, forming ionic bonds by electrostatic attraction, forming a giant covalent lattice structure of calcium sulfate, CaSO4. However, calcium sulfate does not dissolve in the water and is precipitated out in the solution. Additionally, the water molecules are not able to overcome the strong forces of electrostatic attraction between the Ca2 plus and SO4 2 minus ions, and hence there are no effective interactions between the Ca2 plus and SO4 minus ions and water molecules. Hence, CaSO4 does not dissolve in water. Therefore, when you add dilute sulfuric acid to aqueous calcium nitrate, calcium sulfate, a solid ionic compound, and aqueous hydronium and nitrate ions are produced.
Next, we will be looking at the reaction of aqueous ethanoic acid when added to aqueous sodium hydroxide. Ethanoic acid molecules have weak intermolecular forces of attraction between discrete molecules and strong covalent bonds, which are electrostatic in nature between atoms, whereas sodium hydroxide has strong electrostatic forces of attraction between the Na plus and OH minus ions. This is a neutralization reaction between an acid and a base, forming only salt and water. When the two solutions are mixed, we observe that ethanoic acid, or more commonly known as acetic acid, dissociates only partially to form CH3COO- acetate molecules and H plus ions, which react with water to form H3O plus hydronium ions. Whereas NaOH ionizes completely in water to form Na plus and OH minus ions, as it is a strong base. The positively charged hydronium ions are attracted to the negatively charged hydroxide ions by electrostatic attraction, forming water, H2O, covalent compound. Without water molecules, due to the large difference in electronegativity, negatively charged acetate is attracted by electrostatic attraction with positively charged sodium ions to form CH3COONA, the ionic compound sodium acetate. However, in our case, since the water molecules are polar, they will form cages surrounding the Na plus and CH3COO minus ions. The partially negative O will attract the positive Na plus, and the partially positive H will attract the negative O minus end of CH3COO minus. Additionally, since the intermolecular forces of attraction between water molecules and the ions are stronger than the electrostatic forces of attraction between Na plus and CH3COO minus, the two ions will be separated and no precipitation would be observed. Therefore, when aqueous ethanoic acid is added to aqueous sodium hydroxide, CH3COONA and H2O is formed.